Good morning everyone, I am Michael and together with my groupmates Koleen, Yvonn, Helen and Eric, this is the reproductive behavior. Let me have a short introduction about this topic. Reproductive behavior is an obligatory component of the reproductive process. Its purpose is to promote the opportunity for copulation and thus increase the probability that the sperm and the egg will meet. The ultimate goals of copulation are pregnancy, successful embryogenesis, and parturition. In the female, sexual receptivity occurs only during estrus and is characterized by distinct behavior and mating posture. Lordosis, a reflexive posture displayed by female mammals in response to male sexual stimulation to facilitate intromission. In the male, reproductive behavior can occur potentially anytime. Sexual arousal in the male involves a cascade of endocrine and neural events that result in the erection of penis, mounting of sexually receptive female, intermission, and ejaculation. Erection of the penis involves specific neural and biochemical events that culminate in penile vasodilation. Ejaculation is a reflex that is initiated by a stimulation of glans penis and concludes with expulsion of semen. Now let's move on in the stages of male reproductive behavior and specific events in each stage. We can see here in the illustration, the reproductive behavior in the male consists of precopulatory, copulatory, and post-copulatory stages. Courtship-specific behavior is initiated after a sexual partner has been identified. Courtship-specific behaviors including sniffing of the vulva by the male, urination by the female in the presence of the male, exhibiting phlegm behavior, chin resting, circling, and increased phonation. Copulatory behavior varies significantly among species with regard to duration. Lordosis by the female triggers significant sexual arousal behavior on the part of the male. It should be emphasized that lordosis is a highly specific female motor response associated with the willingness to mate. Sexual arousal is followed by erection and penile protrusion. When sexual receptivity of a female is established and sufficient arousal is accomplished in the male, erection and protrusion of the penis ensue. Erection of the penis is necessary for copulation and deposition of semen in the female reproductive tract. Erection is characterized by a marked increase in the rigidity of the penis. Mounting behavior generally requires immobilization of the female and elevation of the front legs of the male to straddle the caudal region of the female. Intromission is entrance of the penis into the vagina. Ejaculation is the expulsion of semen from the penis into the female reproductive tract. Postcopulatory behavior is a period of refractivity. Postcopulatory behavior involves dismounting and a period during which either the male, the female, or both will not engage in copulatory behavior. This refractory period is a period of time during which a second copulation will not take place. Both males and females often display specific postcopulatory behaviors such as vocal emissions, genital grooming, changing postural relationship, and various tactile behaviors, such as licking and nuzzling. Reproductive behavior in the female can be considered to serve the following functions: attractivity, perceptivity, and receptivity. For the attractivity, it refers to the behavior and other signals that serve to attract males. This can include postures, vocalizations, behaviors, and chemical cues such as pheromones that attract the male to approach and engage in procopulatory behavior. Factors such as sexual signal and pheromones, vocalizations, increased physical activity, and subtle postural changes are signals provided by the female that will initiate more intense courtship behavior on the part of the male. Perceptivity refers to the behavior exhibited by females toward males that stimulate the male to copulate or initiate sexual behavior after copulation. For example, head-butting of the male and mounting the male are two of the most common perceptive behaviors exhibited by the females. Perceptivity. It may also include behaviors among females, such as female-to-female mounting that sexually stimulate males. It has been hypothesized that female-to-female interactions, such as homosexual mounting activity among cattle, may serve as signals to initiate male-female courtship behavior. Finally, receptivity is the copulatory behavior of females that ensures insemination. This may include the immobility of standing response, as well as tail deviation or backing up toward the male. The illustration shows the relationship between physical activity and reproductive cycles in various female mammals. Almost all females tend to have a noticeable increase in all-around physical activity when they enter estrus. Greater locomotion is often a sign of increased physical activity. Additionally, it is possible to see milling, exploration, and increase in vocalization and aggressive behavior against other females, practically every species. There is a noticeable increase in physical activity that coincides with ovulation in all investigated species, including humans. This physical activity must be related to mate seeking. Number 1. Reproductive behavior is programmed during prenatal development. During embryogenesis, sexual differentiation occurs, during which the brain is programmed to be either male or female. Very early embryo is neutral with regard to sex. Under the influence of extremely small quantities of estradiol, the brain becomes feminized. Feminization is the development of female-like behavior. In developing males, this high concentration of estradiol in the brain causes the feminization and masculinization of the brain. The feminization reduces the likelihood that the animal will express female-like behavior post-pubertally. Masculinization results in the potential of the animal to develop male-like behavior after puberty. For example, female fetuses exposed to androgens prenatally will display significant reduced female behavior and acquire male-like behavior postnatally. In contrast, males exposed to estrogen or progesterone prenatally are unaffected. In the figure 11.3, we can see the influence of various steroid treatments upon reproductive behavior. Reproductive behavior is controlled by the central nervous system. Reproductive behavior can take place only if the neurons in the hypothalamus have been sensitized to respond to sensory signals. Testosterone in the male is aromatized to estradiol in the brain, and estradiol promotes reproductive behavior and produced in small episodes every 4 to 6 hours. Therefore, there is a relatively constant supply of testosterone and thus estradiol to the hypothalamus in the male. This allows the male to initiate reproductive behavior at any time. The female experiences high estradiol during the follicular phase only and will display sexual receptivity during estrus only. The primary sensory inputs for reproductive behavior are olfaction, audition, vision, and tactility. The degree to which these sensory inputs influence behavior, particularly pre-copulatory behavior, varies significantly among species. Number 3. The olfactory and vomeronasal systems respond to pheromones that trigger reproductive behavior. Secretions from the female reproductive tract serve to sexually stimulate and attract the male to the female. Pheromone is a volatile substance secreted or released to the outside of the body and perceived by the olfactory system and are activated by the vomeronasal organ. Pheromones can also be priming pheromones that have physiologic rather than behavior effects on the recipient. Males also produce sex pheromones that attract and stimulate females. For example, boars produce specific substances that cause sows and gills to become sexually aroused when they are in estrus. 2 sexual attractants are produced by the boars. One of these attractants is a preputial pouch secretion. The second pheromone-like substance is present in saliva secreted by the submaxillary salivary glands. Both compounds have a musk-like odor. Number 4. Phlegm behavior is a close-range investigate behavior. The vomeronasal organ is an accessory olfactory organ. It is connected to 2 small openings in the anterior roof of the mouth, just behind the upper lip. Fluid-borne, less volatile chemicals can enter the vomeronasal organ through the oral cavity by means of the nasopalatine ducts. Vaginal secretions and urine evoke an investigate behavior known as the phlegm response. Phlegm behavior allows less volatile materials to be examined by sensory neurons in the vomeronasal organ. Phlegm behavior is characterized by head elevation and curling of the upper lip. Curling of the upper lip closes the nostrils and allows a negative measure to form in the nasopalatine duct. Thus, less volatile materials can be aspirated through the duct into the vomeronasal organ, where they can be evaluated by sensory neurons in the organ. Phlegm behavior is used to help a male identify mating opportunities. Females will display phlenonin to novel compounds, including the fluids associated with the placenta, newborn animals, and other volatile materials. Phlegm is frequently displayed by post-parturition females as they make identity discriminations between their own versus others' neonates. Auditory stimulation can serve as a long-range signal. Elevated vocalization serves to alert or send a signal to males that sexual readiness is imminent. The auditory stimulus is more useful in long-range discrimination rather than close discrimination. Visual signals are valuable for close encounters. All females display a form of sexual posturing that can be perceived by males. While posturing can be quite subtle, the identification of postures probably takes place easily among members of the same species. Tactile stimulation is generally the final stimulus before copulation. Tactile stimuli from males appear to be important in evoking sexual posture or standing posture by females. For example, biting on the neck and the withers of mares by stallions appears to be more important for sexual stimulation. Biting of the neck of the queen by the thumb is also characteristic reproductive behavior among cats. Rubbing of the flanks and genitalia of mares, whether done by stallion or by a human handler, evokes behavior signals of estrus from the mare that otherwise would not be displayed. Chin resting by bull on the back of the cow just prior to mounting may have some stimulatory effect on the cow. This is a picture of bulls waiting to be ejaculated. Watch mounting and ejaculatory behavior of another bull. Such as practice per-stimulates, boosts and reduces stimulation time when they enter the collection arena. It also increases sperm harvest. A false mount is being performed by the bull mounting the stimulus animal. Number 5. Penile erection and protrusion completes the precopulatory phase of reproductive behavior. Penile erection requires a complex series of neural and vasomotor reactions. Erection of the penis is necessary for copulation and deposition of semen in the female reproductive tract. Erection is characterized by a marked increase in the rigidity of the penis. The increased rigidity is the result of marked increase in arterial flow of blood when compared to the venous outflow of the blood. Erection requires that blood be trapped within the cavernous sinuses of the penis. Increased blood flow to the penis is brought about by vasodilation of the arteriole supplying it. In the bull, ram and boar erection not only involves increased blood flow and subsequent increase in pressure, but a simultaneous relaxation of the retractor penis muscles. Thus, erection and protrusion also involve straightening of the penis to eliminate the sigmoid flexure. The penis of the bull, boar, and ram is fibroelastic in nature and therefore does not increase significantly in diameter during erection and protrusion. In contrast, the penis of the stallion increases significantly in diameter during erection. Number 6. Erection of the penis requires sensory input and a local vascular response. The nervous component is arousal-driven. For example, there must be appropriate singular stimuli in order for the central nervous system to be appropriately stimulated so that efferent neural events can cause an erection. These extrinsic stimuli are called eretogenic stimuli. Their terminal synapse with neurons is so-called behavior center in the hypothalamus. These hypothalamic neurons synapse with parasympathetic and sympathetic efferent neurons that control penile vascular smooth muscle. Erection is caused by the firing of non-adrenergic, non-cholinergic parasympathetic neurons that release nitric oxide, a gas, from their terminals. Nitric oxide is the principal neurotransmitter that drives the erectile process. Nitric oxide causes its effect by stimulating an enzyme, guanylate cyclase, to convert guanylate triphosphate to cyclic guanosine monophosphate. Cyclic guanosine monophosphate causing corporal smooth muscle relaxation and erection results. Copulatory behavior includes mounting, intermission, and ejaculation. The purpose of mounting is for the male to position himself so that intermission can occur. Intermission is the successful entrance of the penis into vagina. Following intermission, ejaculation takes place in response to sensory stimulation of the glans penis. Ejaculation is simple neural reflex caused by intermission, stimulation of glans penis, and forceful muscle contraction. Ejaculation is defined as the reflex expulsion of spermatozoa and seminal plasma from the male reproductive tract. The basic mechanism for ejaculation of semen is quite similar among mammals. Expulsion of the semen is the result of sensory stimulation, primarily to the glans penis, that causes a series of coordinated muscular contractions. Postcopulatory behavior involves refractivity and recovery. All males experience a refractory period before a second ejaculation can occur. The length of time of the refractory period depends on several factors. These factors are degree of sexual rest prior to copulation, age of the male, species of the male, degree of the male nobility, and the number of previous ejaculations. The postcopulatory refractory period is sometimes erroneously referred to as sexual exhaustion. The refractory period should be considered as part of the cessation rather than exhaustion. Sexual cessation refers to a condition in which further stimuli will not cause immediate responsiveness or motivation under a given set of stimulus conditions. Exhaustion is the condition whereby no further sexual behavior can be induced even if sufficient stimuli are present. Now let's move on to the characteristics of copulation, site of seminal deposition, and the number of ejaculations to cessation and exhaustion in the ram, bull, stallion, and boar. For the ram, duration of copulation 1 to 2 seconds. Volume of ejaculate 0.8 to 1 ml. Site of semen deposition, external cervical os. Average number of ejaculations to cessation 10. A maximum number of ejaculation to exhaustion 30 to 40. For the bull, duration of copulation 1 to 3 seconds. Volume of ejaculate 3 to 5 ml. Site of the semen, fornix, vagina. Average number of ejaculations to cessation 20. Maximum number of ejaculation to exhaustion 60 to 80. For the stallion, we have duration of copulation 20 to 60 seconds. Volume of the ejaculate 75 to 120 ml. Site of the semen, external cervical, as but semen enters uterus at high pressure. Average number of ejaculations to cessation 3. Maximum number of ejaculation to exhaustion 20. For the boar, duration of the copulation, we have 5 to 20 minutes. Volume of ejaculate 200 to 250 ml. Site of semen, cervix and uterus. Average number of ejaculations to cessation 3. Maximum number of ejaculation to exhaustion 8. Number 7. Reproductive behavior and spermatozoal output can be manipulated. The degree of novelty of both the copulatory partner and the copulatory environment can be of great importance when managing reproductive behavior in breeding males. The Coolidge effect is defined as the restoration of mating behavior in males when an original female is replaced by a novel female. In other words, a sexual satiated male can be restimulated if exposed to a novel female. Sexual stimulation is defined as the presentation of the stimulus situation that will achieve mounting and ejaculation. The purpose of sexual stimulation is to obtain ejaculation or mating in the shortest time possible so that manpower involved in managing the mating of animals can be minimized. There are 3 approaches used to induce sexual stimulation in bulls used for artificial insemination. These approaches are to induce a novel stimulus animal, to change the stimulus setting, or both. Presentation of novel stimulus animals reinitiates sexual behavior after sexual cessation in bulls. A second approach to achieve sexual stimulation after cessation is to present familiar stimulus animals in new stimulus situations. In other words, changing the location or setting has a stimulatory effect on the satiated male. Sexual preparation prolongs sexual stimulation and increases spermatozoa per ejaculation. Sexual preparation is extending the period of sexual stimulation beyond that needed for mounting and ejaculation. Sexual preparation prolongs the precopulatory stages of reproductive behavior. The purpose of sexual preparation is to collect semen containing the greatest possible number of spermatozoa per ejaculation. In figures 11 to 15, we can see the major steps in sexual preparation resulting in transport of spermatozoa from the tail of the epididymis in the pelvic urethra. 3 approaches are used to sexually prepare a male. These are false mounting, restraint, and false mounting plus restraint. False mounting consists of manually deviating the penis during a mount so that intromission can usually not occur. Restraint prevents the male from mounting even though he wishes to do so. Generally, restraint is for 2 to 3 minutes within 2 or 3 feet of the stimulus animal. A combination of false mounting and restraint will result in the greatest improvement of spermatozoal output. While sexual preparation is taking place, release of oxytocin from the posterior pituitary occurs. Oxytocin causes contraction of the smooth musculature surrounding the tail of the epididymis and the ductus deferens. These contractions transport spermatozoa from the tail of the epididymis into the ductus deferens and eventually into the pelvic urethra. Once sperms gain entrance into the pelvic urethra, they begin to mix with the secretions from the accessory sex glands. Number 8. Homosexual-like behavior. Homosexual-like behavior is common among domestic animals and is particularly common in cattle. In animals, There is not a preference, but rather indiscriminate orientation or same-sex directed behavior. Such behavior has profound uselessness for directing cattle in estrus. When a female stands to be mounted by another cow, this alerts the management team that the cow is in estrus and artificial insemination can be performed. The first explanation theorizes that cows mounting each other provide a visual signal that attracts a bull to the cow in estrus. The second theory explaining the evolution of homosexual-like behavior among cows involves inadvertent genetic selection by man for this behavior. Number 9. Artificial insemination requires an understanding of reproductive behavior and physiology. There are two fundamental ways to collect semen from the male. The preferred method utilizes an artificial vagina or a device that simulates vaginal condition of a female in estrus. The second method relies on the electrical stimulation of the accessory sex glands and the pelvic urethra, and this method is called electroejaculation. Electroejaculation is generally used in males of high genetic value that cannot physically perform mounting and ejaculation. In the beef industry, electroejaculation is used in range bulls. Artificial vaginas consist of an outer casing fashioned or reinforced rubber and a liner that is generally made of rubber that can be lubricated. Temperature and pressure are controlled by the water that is placed between the casing and the liner. One end of the artificial vagina is attached to a funnel-like cone that in turn is attached to a collection vessel, usually a non-breakable graduated test tube. The design of an artificial vagina should accomplish the following: provide a suitable environment for stimulation of the glans penis. Provide an environment that prevents damage to the penis. Provide an environment that maximizes sperm recovery and minimizes sperm insult. The typical artificial vagina consists of a sturdy outer casing, a rubber liner, and a chamber filled with warm water, a rubber collection funnel, and a collection tube. The artificial vagina for a stallion consists of a leather outer casing, equipped with a 2-port drain water. The collection vessel and the productive covering are shown. Ideally, ejaculation takes place in the collection cone, which is 50 cc, that most of the semen will drain directly into the collection vessel. The artificial vagina for the bull consists of a black casing, a rubber liner, a collection cone, and a collection vessel. Water is placed between the casing and the liner. The proper temperature is critical for successful ejaculation in the bull. While not shown in the photograph, a protective covering is placed over the cone and collection vessel to prevent cold shock of the semen. The artificial vagina for the boar consists of a bulb that can apply pressure to the artificial vagina. High pressure is obligatory for the stimulation of the glans penis and ejaculation in the boar. The artificial vagina for the boar also consists of an outer casing, a liner, and a protective covering that houses the collection vessel. The artificial vagina for the collection of the semen from the rams and the bucks consists of a rubber casing, with a valve through which water can be added or emptied, a rubber liner, and a collection vessel. The protective covering is shown above the artificial vagina. Once again, the Group 3 is delighted. Thank you so much and have a good day.